Hello, this is David Shreeve, Algebra 2 instructor with Florida Virtual School. We're going to go over several examples of factoring by grouping. We'll also include, a short review of how to pull out a GCF, identify a GCF, and so we'll look at a few of these. And we're going to do some 4-term and some 3-term. So we'll get a chance to work with both, but really we should look at the 4-term first, because when we do get to the 3-term, we're going to turn those into 4-term polynomials, which will allow us to factor them by grouping. Okay, so just to start out, we'll use a more common example, something a little easier. So we have 5x cubed minus x squared plus 20x minus 4. Okay, if I look at this entire polynomial, there's no GCF that I could pull out of all 4 terms. So I'm going to separate it into groups. That's where we get that term grouping, factoring by grouping. So I'm going to group this, and I'm also going to group the 20x minus 4. So once I group these, I'll be able to pull GCFs out of each group. Alright, so the GCF here, the only thing that they have in common is this is x times x, this is 5 times x times x times x. The only thing they have in common is 2 x's, so x times x, which is x squared. So I'll pull the x squared out of this group, will leave me with 5x minus 1 in the parentheses. Now once I determine this value, I know that I'm looking for this value in the second set after I pull the GCF. So this is important. If we don't come up with the same value, we're not going to be able to factor it by grouping. So the GCF over here is 4, because 20 is just 4 times 5, and 4 is just 4 times 1. So they have a 4 in common, so I'll pull out a 4. Factor the 4 out of the binomial here will leave you with 5x minus 1. As I said, you'll notice that we did end up, fortunately, with the same value here. Okay, we have to have that same value left, or we can't really use the factoring by grouping. This is going to leave us with x squared plus 4 times 5x minus 1. And just as you can with all of your factoring, we can certainly FOIL this back out to make sure that we do get this original polynomial. Okay, and if you'll take the time to FOIL that out, you will get that original. All right. Another quick example of 4-term polynomial real quick. Kind of just keep all these separated. Alright, our second 4-term, it's going to be 12x cubed minus 16x squared plus 3x minus 4. Again, you'll notice there's no GCF that I can pull out of this entire polynomial. So immediately I'm going to go to my grouping. So group these and group these. Alright. Notice here our GCFs are a bit larger here. I can actually, GCF between 12 and 16 is 4, and then between x cubed and x squared is x squared. So I can pull out a 4x squared. I would need to multiply 4x squared by 3x to get 12x cubed. So, and then I would need to multiply it by a negative 4 to get a negative 16x squared. So that leaves me with 3x minus 4 in the parentheses. Remember, once I get this value, I want this same value in the second group here. But it's already the same value. Well, what does that mean? Well, that means I'm simply going to factor out a 1. Everything has a factor of 1, correct? So 1 times 3x minus 4. That way I keep these values the same. They have to be the same. Alright, so 4x squared plus 1 times 3x minus 4. Right, that's your final answers. Nothing additional you can do. All right. Again, we would want to FOIL this back out just to verify that we are coming up with that original 4-term polynomial that we started with up top. Okay. Now let's look at another. This is the last 4-term we'll do, and then we're going to do one 3-term. But we're going to look at one where we might get to this point and then have additional factoring that's necessary. You'll notice on your test questions, typically they're going to ask you to factor completely. So I'll give you an example of something where we might factor by grouping, but still have some more factoring necessary before we can say we're complete with it. All right. So on this one, same thing. No GCF for all terms, so I'm going to immediately group these together. Dealing with the negative values, there's several different ways to do that. Let me rewrite it this way. 2x cubed plus 3x squared. I'm just going to say plus negative 8x minus 12. Okay. And basically, we're just putting a positive 1 coefficient in front of this group. If I distribute that positive 1, we're just going to end up with negative 8x minus 12, which is what we started with. So I'm keeping everything equivalent here. All right, first group, I can pull out an x squared as my largest factor that I can pull out that's common to both terms. That will leave me with 2x plus 3, right? Okay, so 2x plus 3. Now remember, again, I want to get that 2x plus 3 left in the parentheses over here when I factor out a term. All right. So plus, what would I have to factor out here to leave it with 2x plus 3? Well, my factors of negative 8, that breaks down prime factorization to just 2 times 2 times 2, and this is 2 times 2 times 3. So it looks like a 4 will be the largest value I can factor out. Here's the tricky part. If I just factor out a 4, that's going to leave me with negative 2x minus 3 in the parentheses, and I don't need that. I need it to say 2x plus 3. So instead, I'm going to factor out a negative 4. Because negative 4, I would multiply by 2x, would give me negative 8x. And negative 4 times a positive 3 would give me negative 12. So be real careful on your signs when you have the negatives over here. All right, plus a negative 4 is the same thing as minus 4. Okay. And you can see what we're left with is x squared minus 4 times 2x plus 3. But we're not quite done here, because in this particular case, you'll notice that we're not factored completely. We have one of our special patterns over here that we learned about. And this is a difference of two perfect squares, also referred to as a difference of squares. So that factors out to x plus 2 times x minus 2, 2x plus 3. And again, as we should always do when we're factoring, we need to FOIL this portion here. That will give you the, of course, x squared minus 4. And then go ahead and FOIL it with this 2x plus 3 just to verify that you do end up with what we started with up top. Alright, now this last one I'm going to do is only going to have 3 terms. So in this case, when we have only 3 terms, we need to make sure that we are able to factor the 3-term trinomial just by looking at the constant. And there's also a guess and check method we can use, several methods we can use. But before we do anything with factoring, we're always going to check for that GCF first. Alright, so we're starting out 36h cubed minus 60h squared minus 144h. So always the first step is find that GCF. Well, you can break all these down with the factor trees if you want, or just write all the factors out, but I typically want to think of it as taking it down to its prime factorization if you want to find the GCF. In this case, the largest number that'll go into all the numerical portions, all the coefficients here, is 12. Then you can see here I have h times h times h, h times h, and then just h. So the greatest variable I can pull out is h. So I'm going to pull out a 12h. That's going to leave me in the parentheses with 12h times what would give me 36h cubed? Well, it would be 3h squared. All right, I'd have to multiply by a negative 5h to get negative 60h. And then multiply by a negative 12 here to get the 144h. So it leaves me with 12h, the GCF factored out, times 3h squared minus 5h minus 12. And as I said, once we get to, these are more difficult when we have a coefficient by that squared term in the quadratic. So you can use what's called a guess and check method. You can look over the lesson for that. What I'm going to use is sometimes referred to as the AC method, and it does not stand for air conditioner. All right, we're referring to the terms in the actual trinomial here. We consider this our A value, this our B value, and this our C value. In other words, A is 3, B is negative 5, C is negative 12. So the A times C would be 3 times negative 12 equals negative 36. Alright, what I'm going to do is I'm going to find factors of negative 36 that when added together will give me this middle term, negative 5. Factors of 36 that when added together will give me the value negative 5, this coefficient in the middle, or B you could say. So my factors of negative 36 are things like 1 times negative 36, for example, are factors of negative 36. Well, when I add 1 plus negative 36, I get negative 35. That's very far from where I need to be. You could do negative 1 times positive 36, for example. That would give you 35. You could do 2 times the negative 18. That would give me negative 16. Still pretty far off from where I need to be. 3, you could do 3 times the negative 12. That would give me negative 9. So once you write out all those possible factors, you'll find that if you do 4 times a negative 9, you'll get negative 36. But if I add 4 and negative 9, I'll get negative 5. So these are the values that I need. So from this point, we're just going to go ahead and change this negative 5h to an equivalent form, which would be 4h minus 9h. Now, I want to think that I am going to pull factors out of each group when I split it into 4 terms. So if you think about it, if you write 3h squared plus 4h, well, your only GCF there would be h. So I'm already noticing that I've got a negative 9 and a 3. So I'm going to write my negative 9 over by my 3 because I know that I can pull a 3h out of that. In other words, I'm just noticing the fact that the negative 9 is divisible by 3. And you would still get the correct answer, by the way, if you wrote it out, 3h squared plus 4h. But I'm just going to go ahead and put the minus 9h over here by the 3h squared term. Okay, so all I've done is rewritten negative 5h as negative 9h plus 4h. Think about it. Negative 9h plus 4h equals negative 5h. So everything is still equivalent. I have not changed the value of anything. I'm just writing it in an equivalent form that allows me to factor it, okay? So for this first grouping, and I'm going to go ahead and kind of use some brackets here as well. We're going to split it up into 3h squared minus 9h plus 4h minus 12. So once we get to this portion, we're just focusing on what's in the brackets here, and we factor that the same way that we factored all these other 4-term polynomials that we've just done. Okay, so I'm going to factor out from this left group a 3h. That would leave me h minus 3 in the parentheses. And then from this group on the right, I want to have h minus 3, remember? So if I pull out that 4, I'll be left with h minus 3 in the parentheses. So it works out perfectly for me. Okay. And from here, we'll just have 12h. Always remember to keep that GCF out in front here. 12h times 3h plus 4 times h minus 3. Then to check this answer, we would want to FOIL the two binomials here and then distribute the 12h through the trinomial that resulted. Okay? Or actually, that will not result in a... Yeah, it will. It will result in a trinomial if you FOIL that out. Just checking. All right. Hope this helps. And please let me know if you do have questions.